Hello everyone, this is group 14, shear, stacked profiles. Shear is a strain produced by pressure in the structure of a substance when its layers are laterally shifted in relation to each other. This investigation aims to show the effects of shear along various profiles, including single beam, cutted beam, stacked beam, and frame beam. Besides, we tested out a scenario that combines two of our findings together.
The first case illustrates the effects of shear on a simply supported single beam. The positive shear is exhibited on the left side point load, whilst negative shear is exhibited on the right side of the point load.
The second case is a cutted single beam exhibiting self-gravity load. By changing the length of the fish wire, the vertical force between parts of the beam is changed. This case shows the vertical shearing force on the beam interfaces.
The third case further explains case 1. The beam is split into 3 individual beams, exhibiting horizontal movement which causes the wooden beams to slide past each other. The greater the point force, the greater the horizontal force, therefore causing a larger discrepancy between both beams at the ends.
According to the diagram in case 2, self-gravity load or lying load applied on a beam causes a triangular shear diagram, which means that the two ends carry larger shear force and the middle part carries smaller shear force. Hence, in case 4, the X-shaped beam is designed to be stiffer.
The fifth case illustrates the bending moment and shear stress along the clamped cantilever. The end of the cantilever exhibits a greater discrepancy between the wood beams due to the increased distance from the support.
In case 6, each individual frame experiences shear separately along the supports. If the web members could have infinite stiffness, by adding the stiffness of the web member, the shear it takes would increase accordingly, and the moment on upper and lower beams would increase. The overall force of the beam increases, the stiffness at the bottom of the cantilever would increase.
In the last case, we combine the theory in case 4 and 6. There is an X-shaped member between the beams. The cross-sectional area broadens and narrows down according to the diagram of shear force.